Hello and welcome back to this third video for chapter 1. So I want to start here with the overview of database design and the development process, and this will be something we'll be talking about more throughout the chapter, the semester. And so just to give you an overview of what we'll be doing um, when we talk about structured data analysis. So you need to understand how we go from a logical design to a physical design and so on. So the logical design, if we could use the analogy of maybe having house blueprints, what you want to accomplish, how it should be done, um, that's what we're doing here. So this is the time when you're gathering all your information about what it is that you want the database to do, what processes is it supposed to gather data from and help you do your work, what kind of reports should it be making, which also then helps determine what kind of data you got to collect. And so sometimes the logical design, when it gets implemented, then the physical design does not look like the initial logical design. And so I wanted to show you, what that might be. And so if we were looking at students, a student can take many courses, a course can be taken by many students. This is a many-to-many relationship between student and courses. Now, to physically implement that design in a database, we have to come up with an intermediate table for a relational database. And how that's done is, let's say in our student table, we have student ID, first name, last name, address, where the field student ID uniquely identifies this rest of the record. Same thing for course ID, it uniquely identifies that record as well. We might have some additional fields in here. Now, to link these tables, we would link them through this intermediate table. In this intermediate table, in a many-to-many relationship, typically we'll have two field names that acts as the primary key. And so I would link this table to this table based on this. So this is the primary key. This would be considered the foreign key, this particular field here. I would link this table to this table based on these two fields. Again, this is the primary key and this is the foreign key. Together in this table, this makes up the primary key. Then notice I've also got a piece of information listed here, a field called grade. And grade would go in this table because if we look at this primary key, I can't get the grade if I just know student ID, because you could take multiple courses and get different grades in each course. And if I just know course ID, I've got many students in that course. I don't know which grade goes with which student. So I need both pieces of information to uniquely identify this grade. And so that's what the primary key does. So hopefully you get an understanding of what the logical design is, what the primary keys are, foreign key is. We're establishing those relationships, and we're also thinking about data integrity. Now, what I mean by data integrity is that I wouldn't want a student to register in a course if their student ID didn't exist in the system. So somebody can't just walk in off the street and expect to start registering for courses if they're not already in this particular table here. And so the database actually enforces that data integrity, and you're not allowed to put data into a table unless related information in other tables exists. And there are different types of integrity that we could put in. Maybe we wanted to make sure that all this information was there and you couldn't save the record unless it was all there. We also want to say, how is the data going into the database? Do we make this a proper type of text for last name? So those are just different types of integrity issues that a database management system could help you do. So with that, once we've come up with the logical design, we've come up then with a physical design, we have to implement that. And so once we've implemented that, that means creating tables, creating the fields, creating the data types for the fields, and establishing those table relationships. We're also going to be using, the different database management system tools that will help us implement that data integrity. Then we also need to talk about application development. So we've got the database, but now how is the user going to interact with that? And what is the sequence? So we then need to understand the end user tasks and the different sequences that need to take place. And so are they going to, let's say we were implementing this for student registration. So the first thing is we've got to get somebody into the student table first. Then we can start registering them for courses. What kind of outputs or reports would we want from that? And if we have multiple things that we can do, we probably put a menu system in front of all of that, allowing whoever's interacting with the system to do whatever they want. And if you think about TopNet when you register for classes, there's a lot of programming that went on the front end of that database so that you could actually plan your courses, look and see what courses were available. It generates the CRNs, the course numbers for you. You can look up all kinds of data in different ways. And so, somebody had to think about all that and then start writing the code and implementing that. The next thing I want to talk about is the relational database model. So you could look at the history of databases, YouTube video. I've provided you a link here to that history of databases. It's going to talk about Edgar Cog, which is the father of a relational database. He was an IBM research scientist, and he used set theory and first order predicate logic in order to design that relational database. And so what's useful about this database is it solves problems such as data redundancy. Data redundancy means we're having the same data over and over again. And so, like I said before in the previous video, let's say you're tracking, even if it's something small like a customer list. And every time a customer comes in, you gather information and you put it into your database. Well, you're putting in their address multiple times. What happens when their address changes and you're using mailings to send them something? Well, if you don't update all of those different records that have that address in there, then you run into wasting money on sending out those mailings and getting that information to the correct person. So that's what we mean by data redundancy. If we split that up into different tables, then we can link those tables to get to that information. And so if I go back up here and just look at this table again, instead of having this all in one big spreadsheet, and not linking everything, every time we register for classes, I keep collecting all this information as one big record. If something changes, I got to make sure I change everything that's ever been related to this record that we're keeping. So a relational database model helps us avoid data redundancy as much as we can. Not to say there isn't some, but we avoid most of it. It also helps us implement some data integrity, so we get rid of weak data integrity. We can't just enter data in any format that we want. We can actually write little scripts or impose rules that make sure the data is collected the way we need it. One thing is called consistency. if I have a field called state and I need to collect Kentucky as the state, how many different ways can you enter Kentucky? We could do capital K, capital Y. We could do Kentucky spelled out. We could do capital K and then Kentucky spelled out. There are different ways to spell that. And if we were going to query that database and make sure we got all the records that match Kentucky, we would have to include every way that we've spelled Kentucky. Well, it's easier to maintain consistency on the front end, how that data goes into the database, so that when we do a query, we're not having to think of all possible ways somebody might have entered it. So that's what we mean by consistency. Another nice feature is that we don't have to depend as much on the physical structure of the database as we do on the other types of databases that were done in the past, specifically the network database and the hierarchical database. An interesting fact is that the term relational doesn't necessarily come from the relationships across the data, but rather from the set theory that's in math. Should also know that initially the different versions of relational databases weren't successful because the hardware couldn't meet the demands of the database. That is, the processing speeds were too slow, it didn't have enough memory, it didn't have enough storage to run effectively. But that's all been overcome. The next thing I want to talk about is some characteristics of a relational database and the terminology that you may hear. So in math, you might have something called a relation, but in a database, it's called a table. An example might be that student table I showed you above. Sometimes you run into somebody that's been doing this for a long time, since the 60s, although they're probably getting ready to retire. They might refer to a record as a tuple. Remember that a record is just a row in a table, so that might be an individual student in this student table. Also, an attribute from math might be referred to as a field. So a field is a column in a table. And typically the field name goes at the top. Examples of field names out of this student table might be first name, last name, major, so on. So once we have a table and we start to put in some records, it doesn't matter what the order of the records are. We can have them in any order that we want. We talked about a primary key, and so that's the field or fields that is unique value that uniquely identifies the record, the remaining field names that are there. Right? So you don't really have to understand the physical structure of the database like you did in the hierarchical and the network database. When we have relationships in a relational database, there's only three types of relations. A one-to-one relationship, a one-to-many relationship, which is the most common, and a many-to-many relationship. So the connections among the tables are created when you have a shared field. I've demonstrated that earlier. A primary key in one table becomes a foreign key in another table typically. Your tables might be categorized like subject tables, and they might have names like customer, vendor, student, location, building. And then you might also have transaction tables. That might be called sales, registration, orders, visits. So something's changing there. A subject table is typically, once the record's in there, you're not going to be updating it a lot. So the tables can be directly or indirectly connected, and you can access them any way that you want. So there's typically unlimited ways to get it. When you retrieve the data is typically done through SQL or SQL. And SQL is a language, and most databases have some form of SQL to get the data in order to generate reports. Now, some of you may have used Access, some of you may not have. We'll use it in this class. But behind the scenes, even if you're not seeing the SQL, it is writing this code and then executing it. So the commands in SQL that you see here, and there's more commands than this, but these are the basic commands, and they're all in cap letters. So select, from, where, order, by. Either you can put it in ascending or descending order, and then how you want the data to be coming out. And hopefully we'll finish at the end of the semester and we'll be able to do some, learn a little bit more about SQL. But typically you say select, and then you put the field names that you want out of your tables that are linked. And then you say from, and you specify what tables you want this data out of. Remember, you can have primary and foreign keys that are the same but in different tables. In this case, we're only using one table. And we only want to match this. This is an optional phrase here, where city equals El Paso. So if this client name, first name, and last name and phone number will be displayed if they have a city where it matches El Paso. And then I can sort this in order on the output where it looks like this. So some advantage of relational databases. One is there's built-in multi-level integrity. That could be at the field level, the table level, the relationship level, or at the business level. The logical and physical data independence from the database applications exists. That is, you can make changes to the database without impacting the applications that actually use it. So the example might be Google, adds new roads and addresses to Google Maps, but it doesn't change the way the app interface with the database. So they didn't have to go back and rewrite that. There's guaranteed data consistency and accuracy based on the ability to implement those integrity designs. There's easy data retrieval using SQL or what we'll see in Access query by example. And then lastly here, what kind of relational database management systems exist? So there's IBM, Microsoft Access, Oracle, SQL Server, MySQL Server, so on. And so what a database management system allows you to do is create, maintain, and modify and manipulate a relational database. So in addition to building the structures to hold the data, we now have the ability to build the front end on that data with the database management system. That means you can build the input forms, the output forms, you can build reports, you can build separate queries. All of that's part of the relational database management system. And so that allows you to create end-user applications that will interact with that data. So you may be using applications that you don't know what the back end is. And the back end is the database. So that ends this chapter. I hope you've gotten a good overview of what we'll be discussing and why it's important.